My name's Trevor. I'm the Deputy Division Director of Molecular Biosciences. It's one of a number of divisions within the School of Biosciences. We use a range of techniques that span from a very simple biochemical level understanding of how things are operating right through to the whole organism level. So the commercial relationships we have in relation to this particular pathway, I think one of the key ones we have is with a company called Merck Serono. And this work was initiated when I was previously working at the Institute of Cancer Research in London, and then have moved down here and brought some of that work with me. The project is essentially to try and identify small molecules. This is drugs that can be given to patients that will effectively cure them or try and treat them for cancers of the colon, the breast, the liver and melanomas, for example. Other use of our expertise that goes beyond what we're doing within the breast cancer area is really using some of our background expertise in biochemistry in this case, where we're interacting with Orthoclinical Diagnostics. This is a Bridgend based company, and there we're helping them develop or optimize some of their assays by identifying issues that can be solved through the access to the various expertise and facilities that are present within the university. So one of the most exciting recent projects we have is a collaboration with Dr. Paolo Borri, who is an ultra-fast laser physicist. And this is one of the real pleasures in working in Cardiff, because whereas in London I was previously working in an institute that was essentially just cancer biologists, now by coming here I had the exposure to laser physicists who really I wouldn't have had the opportunity to interact with before. We sat down over coffee and we came up with a new solution to a significant problem in basic biochemistry, which is how to work out the affinity of two proteins for each other. And this, at the moment, this type of technology to work out these questions can take many months of work. And we've come up with an approach that has now been patented that would reduce the time to do these types of assays from months down to potentially a day. The technology is still being developed, but has been funded by the Welsh Assembly government, and this is money that has been put in really at a very early stage in the project, when many other funding agencies, less nimble funding agencies, would require an awful lot more proof that something could work before actually taking the risk. I have to say the Welsh Assembly government really put themselves out there. They've taken the risk, and we've taken this project on. It's been through several rounds of funding now. We've raised from the Technology Strategy Board almost £500,000, and this project is now at the point where we have venture capital money has come in, and we're looking to spin the company out. The technology is called nanotether biochemistry, and essentially uses small molecular tethers to hold molecules in close proximity to each other on the surface, and then we measure the proportion of the molecules that are bound as you vary the lengths of these tethers. So one of the big advantages of working in Cardiff, certainly for me, has been the opportunity to work with people at multiple levels within the Welsh system. So this is at the local level, the Cardiff University based organisations, so this will be the Cardiff Partnership Fund, Biofusion, and at the larger level the Welsh Assembly Government through its funding, and also the interactions with the numerous biotechnology firms that exist throughout South Wales. So I think South Wales and Wales more generally has a thriving biotech sector, and that's reflected each year with a very well attended meeting where there's some really top quality work that's actually been shown on numerous occasions.